Did anyone attempt any of the homework for additional practice? If you did, I can uh, answer any questions, anything like that. Give you an answer key if you want to see it, and so forth. It's completely up to you. But we are going to move on to the next part, which is the equation of the circle. We're going to spend today and tomorrow doing the equation of the circle, and likely next week as well. Probably not all of next week. So I did go to the school yesterday. I printed out what I believe to be everything for the rest of the year. So you should be getting 4 separate packets. And those 4 separate packets are, so the first one on top is going to be some weeklies. I think like I printed out like 5 for everyone. That way you don't have to rely on a printer. That way if I do assign one, you don't have to worry about, finding printer or anything like that. You'll have it there for yourself. So there's like 5 weeklies in there. We may not even do all of them. I'm just I printed out things just in case. I printed out some additional things for this specific unit for circles that I did not initially print out. So there's that. And then there is additional topics, which I think we're going to cover after this unit. And those additional topics they're Algebra 2 topics. There are things that I normally would not teach. But I think, given the opportunity, we save a good month of time not reviewing for Regents, so we can use that time to learn new things that you wouldn't have learned otherwise, which I think is kind of nice. Because they're more advanced topics, and just because I say more advanced, that does not mean they're hard. And some of it you will learn next year anyway. But some of it you wouldn't have learned anyway. So I think it's kind of a nice time to, learn some extra stuff. And then the very last packet, which is the biggest one, is what our last unit is, which is 3-dimensional figures, which I don't think it's as nearly as long as this one. So that's kind of what I made for you guys. I don't know the date on when they would get delivered. I know we still have plenty in this packet to do. We have the equation of the circle, which is going to take a few days, and then we have a lot of circle proofs, which I know is going to take a long time as well. So there's some time before you will even need that new material. I just wanted to be a little proactive. All right? So if there's any questions, which I'm not seeing any, let me know. But otherwise, we're going to jump right into the equation of the circle. Now, just like we have an equation for a line, like y equals mx plus b, this is kind of what I'm referring to. Y equals mx plus b, if you see y equals mx plus b, that means it's a line. If you see an equation like ax squared plus bx plus c, equals 0, that is a quadratic or a parabola. So based on how an equation is set up, you can make a prediction on what shape it is going to be graphed. So that's kind of what we're looking at, or about to look at, when we look at the equation of the circle. So the equation of the circle is x minus h, close parentheses, squared, plus y minus k squared equals r squared. Doesn't flow off the tongue as nicely as y equals mx plus b. And you have a lot more letters. But the reality is, even though you have all these letters, it's really not that, it's not terribly confusing. Just like in y equals mx plus b, y and x, you're not, they're just arbitrary. They're just letters that stay in the equation. Same as this x and this y. We're typically not going to plug anything in for this x and this y. But there's only really 2 properties of a circle you need to know in order to graph it. That's it. You only need 2 things, even though you have all these other letters. The center of the circle is number 1, and the radius of the circle is number 2. So you probably predict which thing is going to be the radius, r. But h and k, they're the coordinates to the center of the circle. which it seems pretty straightforward, but there's kind of a little catch to h and k, and we're going to get that into that when we start practicing some of these. But h comma k, they are the center of the circle, which is easy. You know where the center of the circle, you plot that point, and then if you know how big the radius is, well then it's easy. Then you could take a compass, you could draw the whole circle, you'd be good. However, the radius is r. The equation represents it as r squared. So you do need to square root whatever that variable is in order to figure out what the actual radius is. For instance, if this r squared was 36, that means the radius is the square root of that, which would be 6. So depending on whatever that number is, you just got to square root it. And really the challenge with this is just going back and forth. Because sometimes you'll be given the equation, you'll be asked to write the center and the radius, or you'll be given the center and the radius and you'll be asked to write the equation of the circle, which I believe is the very first step here. That's what we're practicing first. We're going to be giving you the center, going to give you the radius, and then we are going to write out the equation from there. That one little catch that I wanted us to keep in mind is the values of these numbers. 5 and 3, they are positive. But look at the sign in the equation of the circle. It's a minus sign, which it's a little bit backwards. It's going to change the sign of the coordinates. So when we're plugging in, if we're going to write out the equation of the circle, it's going to be x. We don't plug anything for that x. And then h is going to be the x coordinate, which is 5. But we have to write the minus sign first. So it's going to be minus, then whatever that coordinate was, which was 5, close parentheses, and square it. So just take note that the coordinate is positive 5, but the equation shows x minus 5. That's kind of the biggest thing you need to be aware of, is that the signs are flipped when going back and forth between equation and coordinates. We can do the same thing with the y coordinate, so it's plus, close parentheses, y minus, and then it's 3. That's the y coordinate. Close parentheses and square it. Is equal to the radius squared, is equal to r squared. So we're going to take the radius and we're just going to square it. If we can do it in our head, great. Or you could write it out as 2 squared, that's fine. But I think we can do 2 squared in our head. So it's equal to 4, because 2 times 2 is 4. And that's the equation of this specific circle. And so now we could plot it, we could visualize it as an equation, or we could visualize it as a graph. Number 2. So we're going to open up parentheses. Now we have a negative coordinate. Internet issues. I know I'm not. So the center here, still write the x. But notice what the x coordinate is. It is negative 1. But we still got to write that minus sign. So it's minus negative 1. And we're going to square it. And this is going to flip the sign because you have a double negative here. It is going to be x plus 1. I know I write the 2 pluses for plus positive 1. The reality is if you know how to flip it, and so forth, you can just flip the sign and just write x plus 1. When you get really good at these, that is probably what you're going to do. You're probably not going to write in minus negative 1. You'll probably just say, oh, the equation, the center says negative 1, so I'm just going to write x plus 1. Plus, it's y. The coordinate is plus 7 over there. And we're going to do minus 7 over here. A lot of people are having connection issues today. I wonder... Let me bring down the quality of the video. Maybe that'll help. Let's see. Welcome to the stream time. See if that... I'm trying to lower the video quality, so that might help. I can't change that. Definitely try refreshing the page, though. If not, you'll still be able to watch the videos later. Lagging every 2 seconds. How many times do you refresh? It must be something on my end if multiple people are experiencing a similar issue. I don't know. I'm going to keep on going, though. Hopefully it resolves. Oops. All right, we're going to set this equal to 14 squared. So 14 squared, you could write out 14 squared. That would be fine. Otherwise, we're going to do 14 times 14, and you get 196. All right, number 3. Now you'll notice the center coordinates are both negative here, -2 and -11. So you just want to kind of be aware of, like, before you're going to really start these things, is that these signs are going to flip themselves. So it's going to be x plus 2 and then y plus 11. So we can kind of jump right into that. X plus 2, close parentheses, squared, plus y plus 11, close parentheses, and square it, is equal to, careful not to write 18 squared, because look at this little thing that they've done to you. They gave you the diameter. Be careful with that. It is the radius squared. You can't square it and then cut it in half. You have to cut it in half right now. So the radius is, in fact, 9, because it's half the diameter, and that's the number you're going to want to square. So 9 squared is 81. All right, then we get to number 4. And that is the first time we're actually seeing a 0. So before I write in the blank, I want to show us kind of what that's going to look like. Another thing I'm aware of is they're giving me a diameter, so I'm going to immediately cut that in half to get a radius. So the radius to this one is 16. But when you plug in 0, look what happens to 0. It's going to be x minus 0 squared. Well, that's something you can do something about, because it's a 0. When you do minus 0, it's just x. So instead of writing x minus 0, you're going to just commonly see that turn into x squared. So if you see x squared just by itself with no parentheses, or a y squared with no parentheses, that just means that that given coordinate is a 0. And then I see positive 9. So I'm going to write out this one. So instead of parentheses with x, I'm just going to write x squared, because it was x minus 0. So it doesn't need parentheses. So if you ever see that, that just represents that there's a 0 coordinate. But for the y coordinate, I do need parentheses. So this one's going to be y minus 9 squared. So notice I flipped the sign because it was positive 9 as a coordinate. That means it's going to be a negative 9 in the equation. Is equal to 16 squared, which is 256. Number 5, the center. -4, 0. Again, I see a 0, but I see a 0 on the y coordinate. So you're going to see that y squared by itself. But the x coordinate is going to be like this. X plus 4. Flipping that sign. I'm going to square it. Plus. Same thing with the 0 right here. You see 0, so you can just write y squared. Equals. the square root of 47. Now, when you square, you still need to square this. When you square a square root, it just, they just cancel each other out, because you'd write this: the square root of 47 squared. That's just going to be 47. So this one you could just set equal to 47. And then the very last one, the center is 15 negative 6 and a radius of square root of 158. Same thing with this one, with that square root of 158. When you square it, it's just going to drop the square root. So this answer would be x minus 15 squared plus x plus 6. Notice the signs get flipped. And then you're going to square the 158. So it's just 158. That looks like that. Okay? Now, it's very important that you are able to kind of go from here to there, because I can tell you right now that this topic does get a little bit more advanced, and it assumes that you can master this right here, because it will get harder. And then on the back page, I know we're going to go backwards with it. I'm going to give you, the equation. We're going to write out the coordinates and stuff like that. So it's going to be very important that we go back and forth, because like I said, when we start doing some of this stuff next week, it is going to assume that you know this stuff, because it does get a little bit harder. All right, now we're going to do given a graph. When you're given a graph, well, you have all the information right there. You can easily find the center of the circle. You can easily count the radius to the circle. So you don't need to be given this explicitly. We could find it ourselves. And that's exactly what we're going to do in number 7. So first thing, well, let's find the center. What are the coordinates to the center? So the center is, let's see, 1, 2, 3, positive 3, down to negative 2. And I think it's very important that you actually physically write out the coordinates. Don't jump into the equation, because a lot of people are going to write x plus 3, y minus 2 in the equation. But you got to remember that sign gets flipped when you're plugging into the equation. So I think it's nice to have it written out right there, and then you can just do exactly what we did. Then for the radius, the best way to count, the radius of the circle, best way to count figure out the radius is go vertically up or down, or horizontally left or right. There's no reason to figure out or count that radius. You don't want to count anything at an angle. But you have 4 radii you can count. How many units from there to the edge of the circle? Looks like 1, 2, 3, 4, 5. And it should be 5 in all directions. 1, 2, 3, 4, 5. Yeah, it is. 5 in all directions. If it's not 5 in all directions, you don't have a circle. But that makes the radius 5. So r equals 5. And now we can plug to exactly what we did before. But I think it's important to write down those 2 pieces of information first. So this is going to be x, got to flip that sign, minus 3 squared plus y. You have negative 2. You're going to flip that to a positive 2 squared equals r squared. The radius is 5. 5 squared is 25. So that's the equation of this circle right here. So far, so good? I hope. Internet issues resolving themselves, maybe? All right, let's take a look at 8 and 9. 8 and 9 are a little bit tricky. I think some of you will be able to figure out what you need to do with this one. We want to find the equation of the circle. That's still the goal for 8 and 9. But something a little bit different. Number 8 says the center is 9, 10, but a point on the circle is 7, 4. You could graph this. The problem is you don't know how big to make the graph. Although if you had a compass, it'd be pretty easy to graph, actually. You have the center, you have a point on the circle, you could just put the point of the compass in the center, put the pencil on 7, 4, and then draw a circle. And that's actually a good method you could do. You could absolutely do that. You do have to be aware of one little thing. That works fine if the radius is, in fact, a whole number. What happens if the radius is not a whole number? Well, we're going to have to do this. I'm just going to sketch this. Because what it says is this center is at 9, 10. But a point on the circle down here is 7, 4. It's more to the left and down. I'm going to do my best to draw a circle. Ugh, they keep coming out as ellipses. Alright, that's good. So now if you have a visual in front of you, yes, just said it, distance. And that's exactly what we're going to need to do. Because you can't, even if you graph this, you are not going to have a horizontal radius drawn from here to here. But if you have methods that can figure out how long that line is, and that line is the radius, which is going to be the distance formula. Exactly. Now just be careful with the distance formula because you don't want to confuse yourself with the letters. That the distance formula, we have a habit of just writing d equals, which is fine because we call it the distance formula. Don't confuse that lowercase d with diameter. This distance is truly finding the radius of the circle because you're finding the distance between 9, 10 and 7, 4. That's exactly what we're going to do. We're going to find the distance. That distance is the radius. So it's this big square root of 9 minus 7 squared plus 10 minus 4 squared. So that's going to become a 4. Right? 9 minus 7 is 2. Then 10 minus 4 is 6. 6 squared is 36. So we get the square root of 40. I'm just going to leave it as square root of 40. You could put it in simplest radical form. I'm not going to. I'm just going to leave it as square root of 40. And that is the radius. So I can, instead of using d, you can just use r. And this is actually a good example of graphing it would give you a decent idea, but it wouldn't give you exactly the square root of 40, because square root of 40 is going to be an irrational number. That's like 6.2 with a lot of decimals. I don't know off the top of my head, but that's kind of, graphing it might give you a good idea, though. All right, now I think we're ready to plug into the circle. Now, when you plug into the equation of the circle, have to use this coordinate. We are done with 7, 4. We don't need that anymore. We've used it to figure out the radius. We don't need it anymore. So the equation of the circle is x minus 9 for the x coordinate plus y minus 10 squared. That's our y coordinate. Equal to the radius squared. We've had square roots as radii in the previous ones. The square and the square root cancel each other out, so you just set it equal to 40, because it would be the square root of 40 squared, which is 40. And that is the equation of my circle right there. Oh, absolutely. You can always use your own subscripts there. So I think this is what you're asking, right? D of r, so the distance of the radius. Absolutely, use subscripts all you want. And there's nothing saying you don't even need a subscript. I mean, instead of calling it, you are using a distance formula, but this specific distance is just r. So you could just jump right to calling it r in the first place. I'd be fine with that because I know exactly what you mean. Because, given the context of the problem, that's the distance you're finding. We can call distances lots of different things. Distances, lengths, radii, diameters. There's so many different lengths that it doesn't matter what letter you call it in the equation. But that's how we do it. We will practice number 9. Same idea. So we're going to do the same exact thing. We're going to do distance formula. I'm not going to graph this one. I think you have a pretty good idea that, what we're doing here. You have the center of the circle. You have a point on the circle. The distance from the center to the point on the circle is going to be the radius. So I'm going to jump right into my distance formula. So this is going to be 1 minus negative 7 squared plus negative 5 minus negative 13 squared. I'm going to switch them to addition because you have a lot of minus negatives. Let's see what we got here. 1 plus 7 is 8. 8 squared is 64. I think I get the same thing on the other side, right? Negative 5 plus 13 is also 8. And 8 squared, again, is 64. So it's 64 plus 64. The square root of, that's going to be 128. The square root of 128. And that is the radius. So we just required us to do the distance formula first. Now we can go right into the equation of the circle. Remember, flip those signs. So it's going to be x. I'm using this coordinate right here. So here's our x coordinate, here's y coordinate. So it's x minus 1 squared plus. You have negative 5, so it's going to be y plus 5 squared. Equals the radius squared. It's the square root of 128. You square it, you just drop the square root. It's actually it's easiest actually when that is already square rooted because it just goes away when you plug into the equation of the circle. And there it is, right there. All right, let's flip over. And we'll take a look at the other side. So we got the center here. Oh, it's more practice on this. I think I'm going to skip these. You guys feel free to practice them. But I'm going to skip them. I think at this point it's going to just become tedious. Because I know you guys are very good with distance formula. We've been doing it since September. Literally since September. I don't think you need to do any additional stuff like that. And I like number 12 and 13. Well, 12 through 15. Because now they're going to give you circumference and area instead. Which is fine. Because remember, ultimately, the two pieces of information that you need in order to write the equation of a circle. You need the center, which I gave you, and the other goal is just any method that you can do to figure out the radius of the circle is going to be good. And certainly knowing the area or circumference of the circle, you can absolutely figure out the radius of that circle. And because of that, because it's the radius, and I've mentioned this in the past, that the radius is better information than the diameter. That's why I find, given the circumference, I will be using 2 pi r instead of pi times d, which doesn't matter. If you did pi times d, you'd still be dividing by 2. But for area, anytime they give us area, we'd be using pi r squared. So we just have to plug into the formula, figure out the radius, and then we can figure out the equation of the circle that way. So up in number 12, the circumference is 6 pi. So I'm going to use 2 pi r. So I'm literally just going to plug in 6 pi in for c. So it's 6 pi equals 2 pi r. Which, when you divide both sides by 2 pi, and this is like one of the first things we did in the unit was basically this. And when things are in terms of pi, that's actually best case scenario because pi's cancel, those 2's cancel, and then 6 divided by 2 is 3. So the radius is 3. So all we need to do now is plug into the equation of the circle. So it's x plus 1 squared plus y minus 4. Make sure that those signs are flipped, which they are. That's always going to happen. You'll notice it was negative 1, now it's positive 1. It was positive 4, now it's negative 4. That's just one of the rules with the equation of the circle, which makes circles probably a little bit more difficult than, say, lines and quadratics. Is equal to, this one doesn't have a square root under it, so we do have to square 3. So 3 squared is 9. So hopefully there's no confusion on where I'm getting any of these numbers from, and hopefully there's no confusion on the signs and why I'm flipping them, because it's just, I mean, it's just part of the rule and the equation of the circle. Number 13. I'm going to jump right into figuring out the radius of the circle by plugging into the circumference formula. So I'm plugging into 2 pi r right now to figure out the radius of the circle. So it's 17 pi equals 2 pi times the radius. And divide both sides by 2 pi. So the pi's cancel out fine. 2's. You get 17 divided by 2, so you do get a decimal here, which is just fine. You can get decimals for these. 17 divided by 2 is 8.5. And that is the number you're going to have to square, so you're probably going to need a calculator for this one, because I don't know what 8.5 squared is, but that is what we're going to have to do. So plugging into the equation of the circle, you have positive 9, positive 12, so both in the equation are going to be negative. So it's x minus 9 plus y minus 12 squared equals 8.5 squared. So for that, I'm going to use a calculator. 8.5 times 8.5 is 72.25. Because that is r squared. So r squared is 8.5 squared, which is the 72.25. I'm just writing it out so everyone can see, how I got that number. Because remember, the equation of a circle requires r squared. Yep, that was sloppy. All right. Now, 14 and 15, same, directly along the same lines. The only difference here is look at the information that they gave you. They gave you area. So area is going to be pi r squared. So we're going to make that plug in. So it's 16 pi equals pi r squared. We just got to solve for r. Now, some of you might be aware, maybe not, it doesn't matter, but when you plug into the equation of the circle, you want r squared. I mean, that's the whole point, right? So you actually, you don't need to take the square root to figure out the radius, because you're just going to end up squaring it again. You're literally just going in one direction just to go right back in the other. So literally, when you're given the area, all you need to do is divide by pi, and you get 16 equals r squared, which is fine. You just got to be aware when you plug into the equation of the circle, don't square the 16. It's already r squared. Because if you did square it, it'd be r equals 4, but then you'd just be squaring that right back. So hopefully that makes sense. You absolutely can if you're more comfortable knowing, because the only difference is you're just not going to have the true radius ever in front of you. But it doesn't matter. You have r squared, so just use it. Especially if it's going to end up being an irrational number. But the radius is 4, but r squared is 16. So you can just jump right into plugging in. 2 negatives, so they're going to flip to a positive. So it's x plus 8 plus y plus 11 equals r squared, which is 16. So you can make an argument that given the area is actually easier than being given the circumference. Because circumference, you have to square the radius, because the equation doesn't have an r squared. And we're going to do the same thing with 15. So a equals pi r squared. 361 pi equals, yep, that's right, pi r squared. Divide both sides by pi. And you get r squared equals 361. And this is a good example of why because I now can do this problem without a calculator. I actually don't know what 361 square rooted is. I don't know if it's a perfect square or not. Doesn't matter. If it is, it's probably like 19. But I don't know. I'm just going to leave it like that. So when I plug into my equation, it's x minus 2 squared plus y plus 2 squared equals 361. And then my signs are right. Yep. And that's all you need to be able to write out these equations. The center and their radius. The coordinates of these things. That's all you need. And we know that there's plenty of different methods we could figure out those two things. So that's really three things. You can get it told directly, you can get it graphed, they can give you the center, a point on the circle, or they can give you area/circumference. Lots of different ways you could figure out this information. All right, going backwards. This is going to be very important, going backwards. And the good thing is about flipping the coordinates is still going to stay true. When we're going backwards, and I'd argue that this skill is actually going to be more important than the other one going forward, is can you read the equation and interpret what the center and radius is? Because I could ask you to take this equation and graph it, just like you would graph y equals mx plus b or quadratic. Look at the equation and graph it. The first thing you'd graph most likely is the center of the circle. But don't forget to flip the signs, because the center of the circle is truly positive 5 and positive 1 because of the nature of the equation. So it's 5, 1. That's the thing that's going to throw off most students, is they'll forget to flip the signs. And they'll say, shouldn't the coordinates be negative 5, negative 1? But you got to flip those signs. And the radius, well, remember, this is r squared. If r squared is 64, now we're going backwards. Instead of squaring it, we're going to square root it. The square root of 64 is 8. And that's it. Number 17. They want the center and the diameter. The diameter, we're just going to have to double the radius, but get the radius first. The center is going to be, well, it says positive 7, negative 2. Just flip the signs. So the center is truly negative 7, positive 2. That's the coordinates of the center. But what about the diameter? Well, this is still r squared, so we still need to figure out the radius. So square root 324, which I don't know off the top of my head. It's 18. So the radius is 18. Now you can go back and forth between a diameter if you want. But don't, for instance, double the 324, then square root it. You'll not get the same answer. Square root it first, you get 18. That we can double, which is 36. So the diameter is 36. It's unusual for them to ask for a diameter, but they could. All right, it is 11:40, and I think I would like to have two other ones to kind of practice tomorrow anyway, and then we have a challenge problem that we can do. And I definitely want to practice this, make sure that we kind of master this stuff. So I think I might actually do the homework page in class just to get some additional practice for us. And then if we have time, we have to review another algebra topic, which is completing the square. Some of you might remember what that is. But I know all of you recognize that term, completing the square. Some of you might have bad memories of it or whatnot. It is completely okay if you forgot what it is. But it is a skill we're going to use to find the equation of the circle. Like I said, this gets harder. So it is... and completing the square is going to be one of those things. But I'm going to go over it. I'm going to teach you the completing the square. I'm going to pretend you don't even know it. Because I might do it differently how Ms. Keener did it, and if that's the case, You can use whatever method you want, but that's kind of what we're kind of leading into. All right, but we are all done. And I will see you all tomorrow.